यस सर, मिल गया असाइनमेंट, भेज दी।
आया दिया है?
हाँ
ओ,
हाँ, आई थी।
प्लीज डोंट लीव अ सिंगल क्वेश्चन. This topic is again bit difficult type of find the center of mass आता है.
वो
No,
एक
no, no,
तो
no, आता है find the position आता है.
तो एक से बताओ,
Thermodynamic
थर्मोडायनेमिक्स इजी होएगा फिजिक्स का?
बहुत इजी है. केमिस्ट्री का?
नहीं नहीं, फिजिक्स का।
हाँ बहुत इजी है. लड्डू.
तो बस एक वही चैप्टर मुझे लग रहा है जो सबसे मुश्किल है, सिस्टम ऑफ पार्टिकल्स ऑफ वर्क पावर एनर्जी।
नो, इट इज वेरी सिंपल. इट इज वेरी वेरी सिंपल एक्चुअली. ओके, दिख जाएगा अभी थोड़े टाइम में. नई टर्मिनोलॉजी है, बट हाँ थोड़ा लंबा चैप्टर होता है. कुछ ऐसे फंडे होते हैं इसके अंदर जो थोड़ा सा ध्यान लगाना पड़ता है और हाथ से लिखने पड़ते हैं. बाकी देर इज नो प्रॉब्लम इन दिस. इफ यू अंडरस्टैंड न्यूटन्स लॉ एंड मैकेनिक्स प्रीटी वेल, इट्स इजी. एक एक्स्ट्रा चीज ऐड हो जाती है उसमें,
पार्टिकल्स।
रोटेशन. दैट्स ऑल. रोटेशनल मोशन गेट्स एडेड. So nothing. So let's talk about motion of the center of mass. Okay. So if you have to study the motion of the center of mass of a system, so VCM, which is the velocity of the center mass of the system, will be given by
डेरिवेटिव है वो?
हाँ dv/dt. सबका इंडिविजुअल पोजीशन वेक्टर ले लेते हैं और निकाल लेते हैं जो भी उसके पार्टिकल्स हैं. उसका origin से r1 is the position vector. So if the system is made up like this, okay, there are these masses and the position vector is with respect to the origin, r1, r2, r3, r4, r5, etc. Then तो ये सबका इंस्टेंटेनियस वेलोसिटी उस टाइम पे होल डिवाइडेड बाय, वैसे तो आई वुड हैव फाउंड आरसीएम, द पोजीशन वेक्टर ऑफ द सेंटर ऑफ मास ऑफ द बॉडीज विच आर लोकेटेड एट r1, r2, r3. जैसे r1 मैंने आपको दे दिया कि r1 इज 2i प्लस 2j. So this is a position vector of the first mass. Then I can give you about second, third. So सबके r1, r2, r3 पता है. और obviously क्योंकि derivative है, so I would write t square here and maybe a t here. So you can take a derivative and then decide the individual velocity at t equal to some instant. Apply the derivative and mass at on each
मोमेंटम
of
नहीं
the
हो जाएगा
particle.
फिर ये, अगर?
हाँ, but I'm going to divide this by
अच्छा अच्छा, फिर
okay because
वेलोसिटी हो जाएगी।
so this will become the velocity of your center of mass. So the point, the center of mass is moving with this velocity if you have to find. Okay, so you said it's a ratio of momentum of the system. You said it's a momentum, right? So it's a ratio of the momentum of the system per unit mass, because it's per kg then, because you're doing the total mass. So you can say it's per kilogram of system. So, so this will fetch you the center of mass velocity. Okay, and you know that similarly, if you have to find the acceleration of center of mass, okay, so the acceleration,
डेरिवेटिव ले लेंगे।
इसी का derivative, acceleration of center of mass. Okay, so ACM is equal to m dv1
अपने
by
ऊपर गामा
dt.
सेंटीमीटर क्यों लिखा हुआ है उधर वैसे, बाय द वे?
Where? Where? अरे this is r यार.
अरे नहीं नहीं, यहाँ पर यार,
Show me.
व्हाई इट इज गामा सेंटीमीटर?
Wait, this is my v,
ओके,
velocity
एंड
of
व्हाई इट इज
center.
सेंटीमीटर?
No, no, this is velocity of center of mass. Okay, so cm
अच्छा,
लिखते हैं. If you find a subscript like cm, he means center of mass.
ठीक है।
Of center of mass, right? ठीक है. Good question. You should know why. तो ये ACM मतलब acceleration of center of mass.
वो मुझे
Same.
गामा लग रहा था हमें।
हाँ हाँ नहीं, वो बन गया था. You're right. Makes sense. पूछना चाहिए. लग गामा रहा है तो clear your etc. then divided by m1 plus m2 plus m3. So you can notice that this is the total external force because this is individual acceleration. So this
ऐसे
is
इसको डबल
F.
डेरिवेटिव की फॉर्म में भी ले सकते हैं ना वैसे.
Can you mean to say d square r1 by dt square? Can. Yes. So F external upon m1 plus m2 upon mn. Assuming there are n. Okay, so this is your equal to ACM. So F external can also be written like this, that it is sum of m1, m2 till mn multiplied by the acceleration of center of mass. So in fact, you treat the whole system of mass as a single mass of this mass, sum of all the masses. And this single mass is being applied a force F external, producing a common acceleration of ACM. Okay. Very importantly, the word external. If you find there are internal forces because of collisions of the individual masses, please do not include any
इंटरनल फोर्स.
internal force in these calculations, in the calculation of.
इसे इंटरनल फोर्स से कुछ खास फर्क तो नहीं पड़ता ना.
हाँ नहीं पड़ता ना भाई, वो तो हम कर चुके हैं. Two bodies collide, equal mass, so they go away. So this was the internal force. External force is when I'm applying like an external force of 5 newtons extra on this. Okay. But
जैसे
हमारे
कॉलेज
case
में
के
तो
लिए,
वैसे भी मोमेंटम कंजर्व रहता है.
right. वो मतलब because there is no external force. It's an internal force. Impulse involved होती है, right? Which is more of internal action-reaction pair. So please do not include any internal force in the calculation, which means the reaction force and the action force, which occurs in a pair always, is to be ignored. If internal collisions are happening, please ignore it. Okay, so ACM is for the external due to, and if there is no external force, remember you can't accelerate the center of mass. Because now you're saying that my F external is 0. So this is all the masses put together multiplied by their acceleration. And you're saying I have no external force and therefore you have no accelerated motion. Right? And therefore what it means is that your momentum is also constant and therefore you have all the internal forces only. So if you put ACM is equal to 0, then momentum is constant and therefore you are dealing with internal forces only. Okay, so all the particles may be colliding internally, but they are not going to change the acceleration of the total system. Okay. So this is acceleration. Okay, what else? Okay, so now center of motion of center of mass in motion. For example, if you throw anything, which has a definite shape and size, for example, and it goes on a earth, obviously if you project anything, it will follow the trajectory, and it may be a rod in your hand, and so you decide to throw a rod, and this rod is then moving, okay, and traveling, and finally it reaches here and falls.
Projectile.
So this is projectile and it is continuously moving. Now if you see, the only force which will be acting on this rod throughout the motion is going to be the which force? Gravity, right? So gravity is the force which is acting throughout. If you want to say, how do I look at this? In this case, will I be able to maintain my velocity, or it is going to conserve? What will happen during this, right? So, but you can see, irrespective of how the rod individually rotates, and the rod may be here, okay, then the rod may go like this. Okay, so the individual particles are turning here and there. So this particle was here and now this particle has come here. It is very difficult to imagine कि क्या होगा अगर आप ऐसे फेंकते हो तो रॉड खुद भी मोशन दिखाती है. बट एक नोटवर्दी बात, व्हाट इज very very key in this idea of that individual particles are moving from one point to another because the rod is going, twisting. But the center of mass of all the particles of which the rod is made up of, that follows a parabolic path. If you see, okay, ये जो parabolic path है वो हम मानेंगे कि center of mass का parabolic है. So the center of mass of rod is following a parabolic path, and the gravity is acting on it. That is one force, right? किसी भी चीज पे जब gravity लगती है और x axis में नहीं होता तो it has to follow a parabolic path. It's a projectile. So you can see this is a rigid body having a definite shape and size, made up of numerous particles of masses, but the center of mass, right, is behaving exactly like a because it is being exposed to an external force of gravity. So like any other projectile, it also demonstrates a parabolic path. So somebody can say, the rod is turning and twisting, but what's happening to the center of mass? So the answer is the center of mass is being exposed to gravitation, and x-axis, the velocity is not changing because there is no source of x-axis acceleration, so it will follow a parabolic path only. So the center of mass is getting exposed to only the gravity. So it is therefore showing a parabolic path. That is an external force on it. Okay, what else? और क्या हो सकता है इसमें? Okay, we've already done that. And I think we did some numerical also, जिसमें bomb explosion होता है, if you remember, right?
या वो कंजर्वेशन ऑफ
हाँ,
मोमेंटम,
yes. उसमें की बात ये है, for
सुपर
example,
इलास्टिक पोल्यूशन भी है ना वो?
हाँ, energy increases, yes. हाँ, ठीक है. But इसमें देखो center of mass के point of view से, if you notice, so you have a bomb, okay, and then you throw it and it follows a projectile path like this. So this has followed a projectile path, but in the air, for example here, okay, in the air, it explodes into 3 parts, and we did this numerical also. That
एयर में तो नहीं है था, मतलब ग्राउंड में था।
हाँ, एक ही बात है, one and the same thing. So
तो फिर वो एक
individual
सा उसका
parts will
टुकड़ा
follow.
सा कहीं जाता है।
हाँ, so here also individual particles will go in different directions, like splinters बोलते हैं जिसको. ऐसे the individual particles, for example, it is broken into 6-7 parts, which you can see, and you can see the velocity of the individual bodies, right? Once it explodes, remember that
और ये सब अलग अलग डायरेक्शंस में जाएगा।
they are going in different direction. But if you do a calculation of the velocity of the motion of the center of mass, what you find is because this explosion happened because of an internal force, the center of mass traverses a projectile motion only. So even after the breakage at this point due to an internal force, the projectile continues with a projectile motion. If you obviously you don't see it, but theoretically, if you see, there was no external force. And if somebody says, okay, chart out the balance trajectory, so you will say, okay, balance तो ये है जी, एक ये जा रहा है, एक ये जा रहा है, तो ये भी projectile ही होगा अगर if it is projected like this. So maybe it goes like this. This is like a horizontal projection. This is at an elevation. This is again an elevation, and this is थोड़ा सा ऊपर जाके it will come down. This will also go up and come down, etc., etc. So may give your argument. Okay, I will see 1, 2, 3, 4, 5, 6, 7, 8 projectile motions. Fair enough, because सब gravity में. But remember, in सब 8 का, अगर आप single equivalent mass का path derive करोगे, तो that again will come out to be a projectile motion, which means this mass will continue to have the same trajectory as it had earlier because there is no external force involved in the collision.
Okay.
Okay, so whatever energy you get, that energy will get distributed in these masses, and extra energy will get because it's a super elastic, and then of course जो भी इसकी momentum थी इस time पे, that momentum also needs to be conserved, right? So momentum, obviously we know ये velocity होगी उसके, we can take 2 components, and then 8 momentums will get added, 8 kinetic energies and potential energies, and kinetic energies will become equal to the initial energy plus the energy of explosion will get. So the center of mass will continue the way it was. If it is exploding at B, we will say that center of mass is still here. Okay, so somebody said, okay, complete the trajectory. You will say my trajectory is this. I'm going to complete my parabola because my bomb did not have any external force. Okay, so let's say, so remember that internal force is not going to impact the motion of the center of mass. And so let's say we have a question in which you have a projectile which is fired. A very similar question. Okay, so let's fire a projectile and let's see what happens to center of mass. Okay, so this is your projectile. Okay, and this is your projectile. Okay. And at the highest point, the projectile breaks down into some parts, and here the velocity, for example, was 200 meter per second. I think if it is the highest point, sorry, it is projected with some velocity of 200 meter per second, and say the angle is 45 degrees, example. U and theta are given, and at the highest point, where the velocity is 200 cos 45, it explodes. Okay, into two masses. One mass is, say the total mass is m मान लेते हैं, and so therefore it splits into m by 2, sorry, m by 3 and 2m by 3. So you have two different masses being catered to. The highest point pit explodes. Now the question is, so one more information, this mass, okay, when it breaks, okay, the smaller mass comes to rest. So you have to find what is the distance from the launching point to the point where the heavier piece falls. So this small mass does not go forward. It comes to rest here only. Matlab it has no velocity, so this is bound to come like free fall, right? It's bound to come like a free fall. And the second mass then is the one which has the balance velocity or the momentum. So iska to सीधा vertical direction में it will come down. The question is, what is the distance of the second mass from the launch point? So this is your launch point. Launch point. Given this comes to rest immediately when it explodes and it starts falling. And the other, so the question is, where will this fall with respect to the launch point? Now, we have already learned that if it's an internal explosion, so the center of mass position is not going to change. And if you have to find the center of mass, the position of this particle, then the center of mass is the range actually. What was the formula of range? U square
sine 2 theta upon g.
Right. So we know U square in this. We know sine value theta is 45. We know g. So you already have been able to
Maximum
find
range आ गई एक तरह से.
so which is, because there is no external force involved, which is what the center of mass will cover as a distance. So this is the distance being covered by the center of mass. But unfortunately, you found out that at the highest point it exploded. But you know, explosion हो जाए, टुकड़े भी हो जाए, you don't have to worry about the individual. But obviously, with the help of this knowledge that the center of mass will reach there, you can, and remember this mass is going to fall here, right? तो इसका तो बिल्कुल r by 2 होगा. So this is xcm by 2, right? और वो दूसरा टुकड़ा हो सकता है, it may fall off maybe here, you never know, it may fall here. So it will have its own, this x coordinate, m1 x1 जिसे बोलते हैं. So you can use that m1 x1 plus m2 x2 upon m1 plus m2. So these two masses will maintain their center of mass in x-axis also. So you know how much is the calculate the total ये कितना आती है ये आएगी u square 200 square sin 90 upon 10. I'm taking g as 10. So this is coming out to be 2 into 2 into 10 raised to power 4 10. So ये आ गया आपका 4000.
4000.
So 4000 meter पे XCM 100% located and cannot change. So
4
your
kilometers.
XCM is here. It cannot change, right? So you already know your position with respect to origin. And now you know XCM can also be calculated using M1 X1 plus M2 X2 upon M1 plus M2. So you know 4000 is the location. And you know the first mass is M by 3. X1 is the half the distance. So this is 2000. Okay, because the smaller piece is falling right here at 2000 meters. And the balance we have to find out 2m by 3 into x2 upon m1 plus m2. Okay, so ये तो कट जाएगा मेरे ख्याल से. So m, this will become m only. So m's will go away and you will be left with 4000 is equal to 2000 by 3 plus 2 by 3 x2. So take it on this side, you will get 6000 minus 2000. 4000 by 3 is equal to 2x2 by 3, right? So x2 is equal to 2000 meters. Oh,
ठीक है.
oh, this also falls here. Calculation check कर ले. नहीं, sorry. 3 fours are 12,000 minus this is 10,000. Okay. So 10,000 and so this is 2, 5,000.
हाँ,
3
सही है.
fours are 12. सही करा ना? 10,000 by 3 है ना?
एक मिनट.
ये नहीं, ये 2/3 भी. अच्छा, 2/3 नहीं है. हाँ, 2/3 है. 3 कट गया.
4000
5,000 meters. 5,000.
into 3. 3 by 2000 into 3 by 2
Yeah.
is equals to x2 है ना.
Yes.
तो 2 से
But
2
where is the
कटा.
subtraction? Where is the subtraction, bhai? This is
अच्छा,
so you already done. You're already done. You've already
नहीं,
done
but
that.
fraction है ना.
4,000 minus 2,000 by 3 is
2000.
10,000 by 3
4000
minus,
into 3.
yes,
uh,
minus 2,000
which is minus 2000 है ना. 12,000
minus 2,000
minus 2000
divided by 3.
divided by 2. 3 में उधर ले गया पूरा
किधर?
इधर.
हाँ ठीक है, मतलब डिवाइडेड बाय 2 कहाँ से? हाँ ठीक है, इट्स ओके. ओके, कट गया.
तो ये आ
5,000.
जाएगा. it is 10,000.
Yes.
yes upon 2 which is 5 kilometers.
So 5 kilometers पे गिरेगा दूसरा.
2000 नहीं है.
So from the origin, the second piece of 2m by 3 will fall at 5 kilometers. Okay. Let's talk about. Okay, so let's talk about one more problem on center of mass. So let's see this. So let me draw a coordinate axis. Okay. So this is your coordinate axis, and so this is the body, and the two masses are there, and they have a velocity which are identical, and so they collide at some point, and you have to find the velocity of center of mass. Okay, so let's say, so this is one particle which is moving towards origin, and there is another particle which is coming towards origin from this point. Okay, so this is 1 point, so this, whatever is the name, okay, so you can call it, this is 5 kgs, this is 2 kgs, so they collide at origin.
Okay.
And the velocities with which they are approaching is 2 meter per second. Both are at 2 meter per second. It's a constant velocity and they collide. Question is, what is the velocity of the center of mass? Velocity of center of mass. What is this color, man? What is the velocity of center of
पेन की
mass?
इंक थोड़ी मोटी कर लो।
यार इससे ज़्यादा हो ही नहीं रही ना, गई, फिनिश्ड,
फिर
बहुत जल्दी खत्म हो गई है।
नहीं,
जाओ
एक्चुअली हमने
जाओ,
पेन की इंक ही मोटी नहीं करी, अब पेन
नहीं
वाले
नहीं,
ऑप्शन में जाओ ना।
आई एम एट थिकेस्ट, माई थिकेस्ट।
ये देखो
Velocity
मेरा।
of center of mass.
अच्छा।
Yours is also gone now. गया ना?
अच्छा, हमने ठीक से जूम नहीं करा हुआ, थोड़ा सा छोटा कर लेते हैं और जूम
ओके,
करके देखते हैं।
छोटा ही करा हुआ मैंने।
ये मतलब टेक्स्ट को थोड़ा सा जूम कर लो आप।
हाउ?
जूम कर लो।
ओके, कर दिया। आई एम
बस
एट ट्वेंटी
कितना,
परसेंट
75% पे कर दो।
75 पे द होल स्क्रीन वैनिशेस,
आप
आउट ऑफ स्क्रीन चला जाता है। अब ठीक है, बट आई एम नॉट एबल टू सी द फुल क्वेश्चन। It is not appearing on the whole page. I can see it now only. Anyway, ठीक है, we'll go to the next page if there is a requirement. So velocity of center of mass has to be found out 3 seconds before the collision. Any thoughts? Since there is no external force at that point, it makes no difference, right? So velocity is m1 v1 plus m2 v2 divided by m1 plus m. So I can write it in vector form and get the answer. You can write the velocity, right? This
हाँ जी।
velocity. And okay, sorry, one information to get this correct is this angle is given to you as 45 degrees.
ओके।
Then only you can break down this velocity as vector.
ठीक है।
तो वो velocity दो हिस्सों में डिवाइड हो जाएगी.
अ,
Actually, it is meaningless, right? What is the point of giving you 3 seconds before the collision?
हाँ जी।
Before the collision is momentum anyways conserved, and after the collision also the momentum is conserved. I'm not sure if how the momentum is changing because of this. This is a standard collision. So one question is what is the velocity of the center of mass 3 seconds before the collision and 5 seconds after the collision? Since there is
ठीक।
no involvement of any external force, why will the velocity of center of mass change? It will stay what it is.
या
Okay.
एड्रेस होना तो वही चाहिए।
G. Second, now, if you can try this, what is the position of center of mass after 2 seconds? Where will be located? Yeah, it is moving with some velocity. After 2 seconds, where is it? And remember, the collision is happening here. Okay, at this point. So you have to find out the position of center of mass, which is moving with a certain velocity, which we can calculate anyway with m1 v1 plus m2 v2 upon m1 plus m2. We can anyway calculate this, right?
हाँ जी, तो ये आ जाएगा, क्या कहते हैं,
So vectorially, obviously, you can calculate very easily.
10।
In x-axis and y-axis, दोनों में होगी center of velocity.
सर इट वुड बी
Velocity.
2 2।
Magnitude थोड़ा चाहिए. We need exact. अच्छा, you know
Exact,
what are
not
you
2।
telling? Position.
I'm telling the center of mass velocity।
Vector में. So when I say xcm, actually I mean vector. I need
Okay, 2,
ij also.
it would be
Because you would know the
2 I cap,
velocity, you
2
would
J cap।
multiply it with 5 seconds.
ठीक है।
तो दैट इज योर, क्योंकि यहाँ से टाइम शुरू हुआ ना आपका t इक्वल टू 0. सो वट एवर कम्स एज अ डिस्प्लेसमेंट ऑफ VCM into 5 seconds is XCM, the new position of X.
ये हो जाएगा।
ठीक है.
तो ये हो जाएगा सर, क्या कहते हैं, 10 सेंटीमीटर्स।
ठीक है. I में, J में, K में, what is it? So you need to find first velocities have to be written in IJK ना. Then you can find x, क्योंकि 5 से तो मल्टीप्लाई करनी है velocity, that's all.
जी ओके.
पहले तो you will find this ना, this vector. Unless you find this vector, how can you find position vector of the XCM? तो पहले तो split it and m1, v1 and m2, v2 and v1 निकाल लो. This is j, right? This is j. So this is moving at 2 meter per second. This is 2j. And what is this?
This is
5
2i cap plus 2j cap.
plus नहीं है. उल्टा बना हुआ है. It is towards this. Actually, it is here.
2
So it
okay.
is minus
2
y and minus j. दोनों ही negative हैं. Both are negative.
minus 2i cap minus 2j.
Correct. Then multiply by the respective masses, find VCM, and then multiply VCM with 5.
ठीक है, हो जाएगा.
ठीक है. Got it.
And same second part भी ऐसे हो जाएगा.
हाँ. Same. VCM निकल गया तो XCM तो सिर्फ into 5 ही तो करना है बस. Because the collisions is happening at origin. So T is equal to 0 पे collision हुआ. उसके 5 सेकेंड में तो you know the velocity anyway is not changing in this question. जब भी calculate कर लो because there is no external force involvement.
Okay.
ठीक है. Okay, let's go to the next page. I think the ink is bothering us. Okay, now let's talk about this question. So you have a situation where you have two masses. Again, let me draw the axis. So I'll make it small so that it fits in. So this is your situation. This is the x and y axis. And one mass is on the x-axis. So let's say one of them is on, yeah. Okay. And the second mass is going at an angle. Okay, so so they are, and they simultaneously started at the common point. So they started here at the origin and they started moving with some velocities. Okay. Now what is seen is that as they're progressing in their direction, so x is noted for them, which means as the time is progressing, you are finding the value of xcm. जैसे भी हमने ऊपर xcm निकाला था, so you calculate velocity, which will remain unchanged because there is no momentum, etc., etc. And then based on time increase, xcm continues to increase, and what they find is that xcm is the straight line bisecting the angle between the given two lines, which means if I draw a line, so xcm का locus बना लिया, he has joined all the xcm's positions of xcm because he knows v is constant. So v is being multiplied by t and new xcm's are being found out, and he's then locating the positions of xcm. What he finds is that the center of mass is a straight line bisecting the angle between the given straight lines. So the center of mass actually is moving like this. Okay, let me, oh, sorry. We have to show it bisecting the, yeah. So this is your, so you can plot your center of mass, and it's a, this is the way center of mass is looking line. And it is bisecting the angle between the two. And the relationship is that this mass is m1 is, okay, this is m2. So m1 is k times m2. The angle between them is theta. So you can call it any angle for that matter. So this is your angle alpha or theta, whatever you want to call it. And the center of mass is bisecting the two. This is the way the motion is appearing. So their center of mass is bisecting the angle between the two. So as the masses are moving, you're plotting the value of xcm. So xcm is vcm into t. You're putting different values of t and seeing here xcm is this line. This is coming. Question is, what is the magnitude of the velocity of center of mass? So VCM निकालना है, knowing that this is theta by 2 and this is also theta by 2, and this is the vector that represents xcm. So this is your y-axis and this is your x-axis. So one body is moving in at an angle. So you can split the motion in ij. So you know VCM will be given by m1 v1 plus m2 v2 divided by m1 plus m2. Okay, and so v1 is this. So let's say this is v1. So I will write v1 as v1. Okay. Okay, there is a relationship between their velocities also. So the velocities are, mass is given m1 is equal to k times, and the velocities are related to each other as v1 is equal to p times v2. So this is also given to us, the magnitude. Okay, so m1 v1, so we know v1. This is our v1. So if I split it into two parts, this will become v1 cos theta I plus v1 sin theta j plus m2, and v2 is only along the x-axis. So this will be m2 v2, which is v1 by p. So v1 by p in magnitude, and direction we know is I anyway. Right, so this is your v2 divided by m1 plus m2, which are also linked to each other like this. So I can write it as, if I replace everywhere, m1 is equal to km2. So this will become km2. This will become k. No, this will become km2. This will remain m2. This is km2 plus m2. So you know VCM vector will, you will get a VCM vector. You will get of all m2s k times आ जाएगा ये, और velocity को तो interchange कर ही दिया, और ये वाला m2 भी कट जाएगा. So नीचे you will get a k plus 1. So you know the velocity vector now at least, and you know its direction is same as VCM because this only will get multiplied with t. So this vector is your xcm if I multiply VCM by t, and since it is bisecting the two, this line, it is a bisector, so the angle it makes with the x-axis is this. So ये VCM का जो angle है अपना पूरा का पूरा, if I have to calculate, I will collect I and I together, and I will write it as V1 cos theta I plus V1 upon P. M2 तो जा चुका है मेरा, but I can write a K here, which has come from mass. So K is again I, and I will separate out the J also, which is V1 sine theta J whole divided by K plus 1. So I know that the tan theta for this, okay, so if I draw perpendicular here, so tan theta by 2 is the angle of VCM or XCM, perpendicular divided by base. Okay, so this is perpendicular, and this is its base. So this will be V1 sine theta upon K V1 cos theta 1. So V1 bhi gaya. So V1 by P is equal to tan theta by 2, right? Perpendicular should be this. Okay, now convert this into, we have to find the magnitude. So magnitude ही आ रहा है, but what we don't know, VCM को मैंने substitute करा. इसमें क्या है, एक V1 आ रहा है ना मेरे पास. I know V1. Put it equal to, so V1 also will go away. नीचे V1 कैसे आ गया? नहीं, perpendicular divided by base will is equal to tan theta by 2. Okay, VCM. मैग्नीट्यूड तो फिर ये हो गया ना, नहीं इसमें बाइसेक्शन कहाँ पे नजर आई है? दैट दिस इज बाइसेक्टिंग, ये इससे आती है बाइसेक्शन। तो इफ दिस इज ट्रू देन इट्स अ बाइसेक्टर बिकॉज इट इज मेकिंग एंगल थीटा बाय 2 विद द एक्स एक्सिस। इससे कुछ निकल आएगा? हाउ कैन आई यूज दिस? बिकॉज द मैग्नीट्यूड विल बी दिस स्क्वायर प्लस दिस स्क्वायर विल गिव मी द मैग्नीट्यूड। द ओनली बैड थिंग इज ये क्या, इसको कैसे यूज करा हमने मैग्नीट्यूड निकालने में? वैल्यू तो निकल गई आराम से। थीटा बाय 2 का कोई यूज ही नहीं हुआ। थीटा से ही हो गया क्वेश्चन। तो आई नो के, आई नो V1 थीटा, V1 P भी मालूम है। So, k स्क्वायर V1 स्क्वायर cos स्क्वायर थीटा प्लस 2k बाय P V1 स्क्वायर प्लस V1 स्क्वायर साइन स्क्वायर थीटा होल अपॉन k प्लस 1 होल स्क्वायर का अंडर रूट। ऐसे ही आ जाएगा ये तो। परपेंडिकुलर if it is bisecting the angle, what was that put to use? कैसे यूज हुआ वो? नो यूज या हुआ कुछ यूज? Unless they say prove it like this, which means my understanding is don't have answer in theta, have all the answer in tan theta by 2. So get the angle as a half angle rather than V1 sin theta. So ये इस इक्वेशन से tan थीटा बाय 2 और sin थीटा ही लिंक होते हैं। तो मतलब ये जो मेरा आंसर आ रहा है cos स्क्वायर थीटा और sin स्क्वायर थीटा, I should get this answer as a theta by 2 answer rather than just the angle between the two velocities. I should get the answer as a angle made by the VCM. To get the question should be find the velocity of center of mass in terms of the bisecting angle which is theta by 2. ये बहुत ट्रिग्नोमेट्री टफ हो गई यार थोड़ी सी है।
क्या सर, क्या है मतलब tan थीटा बाय 2 है ना?
मतलब ये थोड़ा
तो
इसको आई डोंट नो हाउ डू आई यूज ऑल ऑफ दिस। मतलब ठीक है आई कैन डू
tan थीटा बाय 2 को सिंपलीफाई कर देगा थोड़ा।
मतलब I have to convert this whole cos theta and sin theta in theta by 2. So I can do that because I know कि cos theta actually is 1 minus tan square theta by 2 upon 1 plus tan square theta by 2. And in fact sin theta is also 2 sin theta by 2 cos theta by 2 divided by cos square theta by 2 plus sin square theta by 2 is equal to 2 tan theta by 2 upon 1 plus tan square theta by 2. So I in this expression will put this and this. So my velocity magnitude will be in theta by 2. आ जाएगा। उसको खोलेगा कौन बैठ के? Let's do the next one. This is way too long. For as a मतलब it's no longer a question of what should I say? Center of
Physics.
mass. हाँ, this has become a trigonometric problem now. थोड़ा लंबा हो गया क्वेश्चन। But I hope you got the essence. क्या मैथ्स करिए, कुछ भी नहीं थी, कोई खास नहीं थी। एक वेक्टर लिखा और उसको उसका मैग्नीट्यूड निकाला, बट मैग्नीट्यूड उसके हाफ एंगल में निकाला instead of the angle between the two vectors. That's all. So no, nothing great. The complexity has come because of that k, etc., etc. Okay, let's do one more. So let's say you have a situation where you have so there is a wedge. Okay, this is your wedge. This is your wedge, and you have two masses. Okay, on either side. So one mass is on the left hand side, which is this, and both are connected, not connected to each other. Okay, and now what is happening is they are equal masses, m1 m2, m1 is equal to m2 is equal to m. They are released, and both were released from the top. Okay, both were released from the top. They go like this, in the respective directions. This angle is 30 degree and this angle is 60 degree and this is 90 degree. You have to find the magnitude of acceleration of center of mass of the two block. So both bodies are accelerating. One is going like this, the other is going at g sine 60 and g sine 30. And you have to find the acceleration of their center of mass. So ACM we already know is, कैसे निकाला था हमने, M1 A M A अगर A ना, सॉरी हमने 1 रखा है तो M1 A1 प्लस M2 A2 upon M1 plus M2. So we know this acceleration and we know this acceleration. And we know the acceleration of this. We know the acceleration is g sine 60. This is g sine 30. The center of mass will move accordingly. So you can put the vector sign. Please ensure that when you put A1 as this, so be clear that this is to be put in two directions. अच्छा हमने इसको वो मान लिया ऑलरेडी g sin 30. तो इसका नया जो है वो यही है. So this is its new axis, right? तो ये ऑलरेडी g sin और g cos हैं और एक दूसरे के परपेंडिकुलर है. So if you treat this as I, then the other one becomes j. So one is I and the other is j, perpendicular. जैसे normal reaction perpendicular होता है इसके. So ये वाला perpendicular है. If you consider this to be I, then the other one is j. So be very careful when you write A1 and A2 values. So one you will write as a j, the other you will have to write as a I, or vice versa, and then calculate. So these are vectors. So you'll get a center of mass vector. Any doubts in your mind?
No, sir.
थोड़ा सा मतलब. All right. So let's say one more situation. And this time you have two masses which are approaching towards each other. Okay, so there are two masses and they are approaching each other. No shape, size, nothing is given to you. It's a smooth horizontal surface. So this is your smooth horizontal surface and these are your two masses. कुछ लिखा नहीं हुआ, I'm just drawing it. Two masses are there and they're moving towards each other. Their accelerations are 2 meter per second square. So one is moving rightward with 2 meter per second square. The other is at 3 meter per second square. So this is 2 kgs. This is, for example, 5 kgs. They're moving towards each other. Question is, what is the acceleration of center of mass? Can you try this?
Acceleration of center of mass.
ACM. Together they have a center of mass, and what is the direction?
Coordinate system ले ले कोई.
हाँ, मतलब you can, that we've already done, right? Because a plus right hand side is I, right? And left hand side is
2 I
minus
cap
2I.
and minus 3 I cap.
Yes, that's your acceleration vectors individually.
2 meter per second. ये तो velocity. अच्छा per second square है.
Yep.
Okay.
So be careful. We are doing again M1 A1 plus M2 A2, but we are adding vectorally.
It is 4 I cap
Yes.
minus 15 I cap
Yes.
upon 7.
ठीक है. So
Which
you
is-
have done so your center of mass is accelerating towards the left. So meter per second square, right? So fair enough. Perfecto.
Effecto.
Spanish. O लगा. Put an O in front of English and make it Spanish.
वैसे Portuguese भी हो सकती है.
Also can be. Okay, I haven't heard Portuguese. I want to go to Portugal, however.
Portugal नहीं Brazil जाओ फिर.
Brazil. क्या? वो तो तब जाए ना फेस्टिवल होता है जब.
Rio de Janeiro.
Yes. Rio de Janeiro. Yes. Okay. One more. Simple one. So now you have a system which is a pulley. So you have a pulley. This is your pulley, and so there are masses connected. We have done similar questions to find the common acceleration. It's the same string,
एक्चुअली
which
हमने
is
ये उसमें मैकेनिक्स में करी थी.
हाँ. तो अभी हम उसको अलग we'll see from other point of view. So you have this going down, okay, and now the string is coming to the other side. Okay, and the situation is that it's a common string, and so one mass on the LHS. Okay, so this is your mass on the LHS, M1 and M2. These are your masses. So this is going up and this is going down, and they're connected to the same string. Okay, and so acceleration is given to be a. So this is going up with a. This is coming down with a. Obviously, it's a common string. The question is, and the masses are also given, M1 and M2. The question is, what is the acceleration of the center of mass of this system?
ठीक है.
ACM निकाले. So see them as a collective collection of two masses, and if they have a center of mass, how that motion can be defined.
ए आई कैप है, जे
ठीक है.
कैप,
हाँ ठीक है. One is J and the other is minus J.
माइनस जे,
Yes.
यानी कि
Downward
प्लस
is
ए जे
minus J.
कैप.
Yeah.
तो
So
ये
masses are given to be, so one is 1 kg, 1 kg on, sorry, it is 1 kg and 4 kg. So ये 4 किलो है.
ए जे कैप प्लस M1 प्लस M2.
Okay, where is the minus sign gone?
ओ
Minus J का. Should be there.
नहीं, माइनस जे वो कट गया ना.
किससे?
मतलब ये माइनस माइनस ए था ना, माइनस ए इंटू माइनस जे प्लस ए जे.
Scalar product कैसे आ गया? So you are doing A1 M1 plus A2 M2 upon M1 plus M2, right? This is what you're doing. So how do you get this? This is, one of them is going upward,
इट
so it
इज
will be,
ए एंड, अच्छा ठीक है.
how do you get a
तो
dot product
ए
here?
जे M1
हाँ.
ए जे कैप माइनस M2 ए जे कैप.
Yes. And I've told you the mass M2 is 4 kgs and mass M1 is 1 kg.
ठीक.
So this is 1
ए
kg.
माइनस 4 जे कैप
Yes.
अपॉन क्या है,
5. 5.
इट वुड
That's
बी
a,
माइनस 3
yes,
जे
that is
कैप
your
अपॉन
ACM. That's your ACM.
ए सी ओ एम.
Correct.
ठीक.
Okay, now the world's most famous question of center of mass. When I say, well, I'm just making it dramatic, it is not. Okay, so let's talk about the center. Okay, so let's move to the next page because I think this is also full. Okay,
कितने पेजेस बना सकते हो मैक्सिमम आप?
I have not tried, but after a while the ink will finish. ये अपने आप ही ink खत्म कर देगी हमारी. They have this
सर
trick.
एक और पेज 4 बना के दिखाओ एक.
बन गया.
ठीक.
Okay. Now the question is, you have a log of wood. So there is a log of wood like this. So this is a log of wood. A man is standing on it, and this log of wood
कहाँ
is
पर
at a
हो?
certain. I'm on
सर
the,
पेज 4.
yes, I'm on the page 4. So this, let me just draw it down below so that, okay, let me draw it up so that you have a place to write. This is a log of wood, and this is your river. Okay, so there is a river bank available. So this
ठीक है
is
ठीक है, वो
your,
बनाने की जरूरत नहीं है. ओके.
ये रहा, just so that you know what's happening. And there is a man who starts walking.
इतना ऊंचा बैंक. ओके.
Oh, don't, वो नीचे लिखने की जगह है, यही ग्राउंड है. ठीक है. तो ये सामने, so what happens is No, it is on the river. This wooden log is on the river.
या
ओके, ये इसका वो है किनारा, तो बंदा जो है वो इधर है. सो द मैन इज हियर. सो द
नहीं नहीं,
मैन इज
आप
हियर.
पहले बोल रहे थे मैन जो है लॉक के ऊपर है।
हाँ है. जीरा. मैन ये रहा, लॉक के ऊपर ही है.
अच्छा,
जीरा. सो दिस इज योर
मुझे
मैन.
थोड़ा डायग्राम, एक मिनट।
जीरा मैन.
सर मुझे थोड़ा सिंपल सा डायग्राम।
हाउ विल यू मेक अ लॉग यार? हाउ इज दिस डिफरेंट?
बस बस।
ठीक है. स्टे हैप्पी.
और
Okay,
ये
now the
नीचे
man
रिवर है।
starts moving here towards left. Okay, towards the bank. And the mass of the log is capital M. This is M. The length of the log is L.
एल।
Yes. So this is L given. And it is touching when he starts the motion. So this is your initial situation. The log touches the bank. But as the person starts moving forward, a point comes when he sees by his motion the log actually shifts in the backward direction. Okay, so the log reaches here when the man is at the end of the log. तो बंदे ने चलना शुरू करा और चलते चलते what he notices is the log is going backwards. This is your log and it is going. This is your man. So this is the situation. And then of course you have a. So the log moves by a certain distance x from the bank. ये distance हिल गया वो. So you have to explain why this happened, and then you have to explain the displacement x, which has happened because of this whole. The man's mass is m. Okay, so the mass of the man is small m, log is capital, and the length of the log is. So you have to explain why this happened, and why this movement happened, and what's happening in this. ये पीछे क्यों आ गया उसके आगे जाने से? और फिर you have to calculate the displacement of the log because of whatever is driving this behavior of the log. क्या हो रहा है ये? क्या हो रहा है ये? What's happening?
ये बताना है क्या हो रहा है इसमें।
पहले ये बताना है, उसके बाद ऑब्वियसली कैलकुलेट करना है उसकी हेल्प से, उस कॉन्सेप्ट की हेल्प से कि व्हाट्स हैपनिंग. बंदा आगे जा रहा है, लॉग पीछे चलता जा रहा है, उसको उतरना था. ही वांटेड टू गेट ऑफ द एंड जंप ओवर, मतलब टू द. अनफॉर्चुनेटली इज नॉट एबल टू डू दैट बिकॉज द बैंक, ये लॉग पीछे चला गया. वाई?
ऐसा क्यों हो रहा है? पर ऐसा क्यों होगा वैसे?
क्यों होगा? दैट्स अ क्वेश्चन. Because you're studying a particular topic, think in terms of the context, which is your context is what?
सेंटर ऑफ मास है।
है.
ये तो नहीं समझ आ रहा। एक छोटा सा हिंट दे दो।
यार, देर इज नो एक्सटर्नल फोर्स, सो
तेरे से
द
इंटरनल।
सेंटर ऑफ मास कैन नॉट चेंज, इट
ठीक
रिमेन्स
है।
वेयर इट इज।
ओके।
एक्सीएम इज वेयर इट इज, राइट? सो जैसे कि हमने प्रोजेक्टाइल में देखा था, वो फटा और वो दूसरी बॉडी वहां गिरी, द सेंटर ऑफ मास की जो पोजीशन थी इन द एब्सेंस ऑफ एक्सटर्नल फोर्स, वो 4 किलोमीटर ही थी। एक गिर गया था 2,000 पे, एक गिर गया था 5,000 पे जाके, वो हमने निकाल लिया था। समथिंग वेरी सिमिलर इज हैपनिंग बिटवीन मैन एंड द लॉग सिस्टम. So they are m1 and m2 respectively in this case. Look at that. दोनों के कोऑर्डिनेट्स देखो, और जो वो है लॉग, जब वो स्टार्ट कर रहा है मोशन, तो उसका सेंटर ऑफ मास, लॉग का जो सेंटर ऑफ मास है अपना, वो तो सेंटर ऑफ द लॉग ही हुआ ना। इट्स अ यूनिफॉर्म लॉग। सो ये जो लॉग है, इसका अपना पोजीशन ऑफ सेंटर ऑफ मास तो यहीं पे है, इसका जो एक्स है तो वो L/2 पे है, और जो बंदा है उसका L पे है। तो m1 x1 प्लस m2 x2 डिवाइडेड बाय m1 प्लस m2 तो पता ही है एट द स्टार्ट पॉइंट, तो xcm तो आ ही जाएगा।
ठीक है।
अब xcm आ जाएगा तो फाइंड द xcm अगेन विद द न्यू पोजीशन, वेयर द लेट द डिस्प्लेसमेंट भी x, लेट द डिस्प्लेसमेंट भी x। लेकिन बंदे के केस में जो m1 x2 होगा, m2 x2, दैट विल बी m इंटू x2 ओनली। ये m1 इंटू x, इसका मान लो m2 है, एम एन m2 है, और जो लॉग है वो यहां पे आ गया, उसका जो डिस्टेंस है ओरिजिन से, दैट इज, ये तो चेंज नहीं होने वाला है, तो सेंटर में रहेगा इसके। सो वो होगा L/2 प्लस एक्स into the mass of the log, and that divided by again the same quantity should also be equal to the previous xcm. So
ठीक।
the ratio, समझ में आया क्या बोला?
हाँ।
हाँ, डू इट, लिख के देखो इसको, दैट्स ऑल यू नीड टू डू। सो फाइंड द एक्सीएम हेयर, find the XCM here and make them equal to get the displacement. So the displacement happens because the center of mass needs to adjust itself in the absence of external force. It has to.
ओके।
It's a very nice thing. Center of mass.
मैथ्स
हाँ,
कॉन्सेप्ट।
yes. Something very
और
similar.
सिस्टम ऑफ पार्टिकल्स में कोई फिजिक्स वाले क्वेश्चंस भी हो गए क्या?
ये फिजिक्स ही है भाई, इससे बड़ी फिजिक्स क्या होगी कि ये नजर आता है ये, एटलीस्ट यू कैन सी इट।
ठीक। ओके, समझ आ गया।
एक्स निकल आएगा।
हाँ जी। एक्स इनिशियल इज इक्वल्स टू एम एल
यस,
प्लस एम एल बाई
बाई
टू
टू। करेक्ट,
अपॉन
सही करा, सही सोचे हैं अब।
एम प्लस कैपिटल एम।
यो
और जो
यो यो यो
जो फाइनल डिस्प्लेसमेंट होगी
जी।
होगी एम एल प्लस एम एल बाई टू प्लस एक्स अपॉन एम प्लस एन। तो
You
x इनिशियल इक्वल्स टू x फाइनल, उस समय x की वैल्यू कैलकुलेट।
correct. You got it. You got it right.
जी, अगला क्वेश्चन।
Yes. 2 minute break here. थोड़ा
आइस
the,
के।
no, not ice, brain here. थक गया मैं. Tired. So many questions on center of mass, but it is important to get you exposed to this because you will see these.
दिस इज मैथ्स।
This is not maths. This
दिस
is
इज मैथ्स।
this is pure physics. The maths क्या
हाउ
है?
द फॉर्म।
First, it was precedented by a reasoning. What exactly is happening? Because if you don't know what's happening, you can't write this equation. It's very difficult. Hence, not because it is a formula.
ओके, फिजिक्स एंड मैथ्स।
मैथ्स वो वाली तो फिर दुकान पे भी चलती है भाई. बिस्कुट खरीदना है तो भी मैथ्स ही चाहिए.
फिजिक्स मैथ्स। ओके, फिजिक्स।
खुश रहो बेटा, जो मर्जी बोलते रहो. ये बदलने नहीं वाला फैक्ट. हॉरिबल.
सर दुख रहा है।
Okay, now you do this one. Okay, a question. Let's see if you can do this. Just apply yourself. All right. So we are here. Okay. So an explosion takes place and the particle is divided into three parts. Yeah, I think you can do this. Yeah, you've done this before.
न्यूक्लियर बॉम्ब।
Yes. You know conservation. So it's an internal collision type, super elastic
हाँ
वाला
जी।
case है,
या
जिसमें it breaks into three parts and you have to find the mass of the third one. So okay, let's do it. कोई बात नहीं, हमने कर रखा है something very similar.
ये
Okay,
हमने
हमने
इसमें करा
ग्राउंड पे
था।
करा था.
इसमें क्या
ठीक है.
हवे में है?
नहीं ये भी वही है. So this breaks into three parts. So let
थ्री
me just
पार्ट्स।
draw the three parts. One, then you have the second one, and then the third.
स्मूथ क्रिएट कर दो।
Yo. Okay, so you have this one, two, three. Okay, the two masses are at right angles if you see. Okay, so these are at right angles and the masses are given by 1 and 2 respectively. So this is 1 kg and this is
बॉम्ब का से मास कितना था?
1 kg. हाँ जी.
बॉम्ब का मास।
किसका मास?
बॉम्ब।
हाँ. ओके, वो नहीं बताया उन्होंने. तो फिर तो यू विल जस्ट सब्ट्रैक्ट, नो. So it explodes and goes into three parts, and the velocity of this is 12 meter per second, as shown in the diagram. The velocity of the second piece is 8 meter per second, and you have to
And then there
find,
is 4 meter per second.
yes, and this is 40 meter per
40 मीटर, अच्छा,
yes.
बहुत बढ़िया.
तो आपको
और उसका
निकालना है,
मास क्या है फिर?
ढूंढना है, find the mass,
ढूंढना है. ओके.
and this is the angle at which it leaves is theta, and okay, थीटा आ जाएगा, हाँ आ जाएगा, थीटा है. Okay, so this is not three dimensional, okay, this is collision in two dimension only, but so I will just draw a line to ensure कि ये doesn't look like a three dimensional question. Okay, so let's call it a, ये आ गया आपका, right? So this is actually an xy plane only. The whole experiment or situation is in xy plane. So this is your y axis and this is your x axis, and you have to find the theta is also unknown, the direction in which it has gone, but you have to find the mass of this piece. So m3 is to be found out, and knowledge of theta is not available.
Okay.
Now that is what makes it bit,
मुश्किल.
कह सकते हैं, does.
तो बॉम्ब का मास मिला था तो ये आराम से हो जाता.
फिर there was no work to be done, no physics to be applied. So it's a case where an internal explosion has happened. Think in those lines.
सुपर इलास्टिक कोलिशन.
Yes.
उसका फॉर्मूला.
Formula nahi, think in terms of your approach. How will you approach it now because you know something about it?
थीटा कैसे निकाले? आप से वेक्टर्स की फॉर्म में लिख ले पहले.
No, but what is the concept you will use? That will drive the formula. That will drive whether vector is. पहले तो concept है ना दिमाग में. ये concept से मैं करूँगा. उसके बाद तो फिर then it's some tool, right? Some tool is required. Vector could be a tool, but vector is not the solution, right? What is the approach? What is your approach? How are you going to approach a problem of
The
super
total
elastic
linear
collision?
momentum is conserved.
Correct. Now you know momentum is a vector. So write all the quantities in x-axis, y-axis, break down all the
So
x-axis.
total momentum, total final momentum is equals to 0. No?
You mean total momentum, initial momentum is equal to final momentum, not equal to zero. Yeah, it is
Initial
equal to zero
momentum.
also because the initial mass is at rest. Yes, you can say that. It is. Total momentum is equal to initial momentum is equal to zero. Conservation भी लगाओगे, and you know the value of the initial momentum of a bomb at rest on the ground is zero. Yes, apply this. So you know, spot on. And now it's maths. How you
Yes.
manipulate all those things.
Okay. Cool. Very cool.
Fevicol? What is
नहीं,
Fevicol?
very cool.
Very cool. Okay. Speaks French में बोलो भाई.
क्या बोलते हैं फ्रेंच में?
Jean.
Trevian. Trevian.
Gravia. Okay. That's French. Gravia. जैसे चिकन की
Trevian.
ग्रेवियाँ होती हैं. हाँ. How do you spell it?
लिख दो. Written.
Okay.
Trevian.
So it's gravia. Chicken की ग्रेवियाँ. Okay. Oh no. Tre.
Three.
Trevian. Okay.
Yeah.
Trevian.
Trevian.
Too tough.
सर आप अगर सीखोगे ना फ्रेंच, आपको फिर टफ नहीं लगेगा.
I agree with you. But I'm more interested in.
इंग्लिश से बहुत इजी है.
My interest is in Bollywood music right now. I have joined. I have not paid them the money, but I have taken a trial class, Atrium Academy, online.
तो इंस्ट्रूमेंट भी सीख लो, नॉर्मल है।
और यार वो बहुत टॉल हो जाएगा, बहुत मुश्किल हो जाएगा। उतना सीख लूंगा थोड़ा बहुत जब गाना आ जाएगा कि
फ्लूट
उसके
सीख
साथ।
लो।
My aptitude is tabla actually. I want to learn harmonium, but my aptitude is tabla.
एक मिनट, मैं डायरेक्शन कुछ गड़बड़ लगा दी।
Be careful, because
वो
थर्ड वाला जो
वेक्टर से
मास है
फॉर्म में
उसके
लिखो ना,
उल्टे हैं।
वेक्टर से फॉर्म में लिख लो। क्या?
ना, यस।
12 आई कैप, नहीं 12 जे कैप प्लस 2 आई कैप, और ये हो जाएगा -40 आई कैप -40 जे कैप, ये वाला ना।
ठीक है, cos थीटा sin थीटा भी कर सकते हो फॉर द थर्ड थर्ड वेक्टर।
ये ऐसे भी लिख सकते हैं ना इसको, ऐसे।
हाँ, कैन sin थीटा cos थीटा। थीटा कैन ओनली बी
तो
एलिमिनेटेड बाय
12
sin
जे
स्क्वायर
कैप
थीटा। हाँ।
प्लस, एक मिनट, अच्छा ये 8 है, प्लस 16 आई कैप -m3 इंटू 40 आई कैप प्लस 40 जे कैप इज इक्वल टू 0। आई कैप प्लस 0 जे कैप, एक तरह से, है ना।
एक्स और वाई एक्सिस में आई थिंक देयर इज नो पॉइंट यूजिंग दिस, बट एनीवे इट्स योर चॉइस, कैन डू इट, बिकॉज दिस विल बी cos थीटा sin थीटा। ये तो डिवाइड होगा आई जे में, so x में you have to keep it equal or zero, and then y में also you need to do the same thing. A, but where is the components of this? इस third कहाँ गया?
थर्ड का ये रहा है सर, 40
कहाँ
आई
है?
कैप और 40 जी कैप।
No, but you don't know theta, right? 40 cos theta plus 40 sin theta. ये तो
आई
40 is
कैप
in the
जे
at
कैप।
an नो, मैं वो लिखना था उस परपेंडिकुलर और उसमें होता है ना, रेजोल्यूशन का करिए, वेर हैव यू रिजॉल्व्ड। So this is your y component. How much is a y component? If hypotenuse is this. ऐसे सोचो ना. What do you mean just by putting I and j you'll get the values? 40 then is in I and j both. So you've forgotten how to do resolution.
नहीं
So
नहीं,
this is 40 and this is 40 sine theta with a minus
थीटा
sign.
प्लस -40 साइन थीटा एंड
Minus 40
40
cos.
कॉस कॉस
Yes,
थीटा।
yes. So that is
तो
what you will
मतलब
put here.
उसमें लिख दूँ तो
Actually, you have to write I and j, compare both the sides I and j in the next step. So this will be collect all the j's, collect all the y's, and put them equal to 0 individually. Whenever you do law of conservation of momentum, you do in two dimension. That is why you use this x and y. So law of conservation in x-axis and the law of conservation j, both are to be applied individually, separately, not together. Although you can write this, but finally this will also be j versus j and I versus I comparison individually. Coefficient of I on the left hand side will be 0. The coefficient of j on the left hand side will also be 0.
बट -40 साइन थीटा को हम किसी यूनिट
No,
वेक्टर की टर्म में।
no, but you could always write a 40. पहले तो I don't see any 40 sine theta in your expression. You
हाँ
don't have
हाँ।
any. How will you introduce it? Equation is wrong.
12 j cap plus 8 I cap minus m3
Okay.
minus 40 sin theta plus
I think you should practice momentum, writing it down vectorially. Now you're again mixing I and J. You should write I x-axis momentum separately and y-axis momentum separately. You're mixing them again. No point.
12 j cap plus 8 I cap
Is what?
is
You
what
mean this
is
is y,
हाँ जी,
momentum in y, py, and this is px.
yes, yes, एक मिनट 16 I cap is equals to 0.
ठीक है. Now write the. I don't think so that this is true. Because when it breaks down, the third mass is also involved. You have to write for the third. So P first mass plus P2 second mass and P3 is equal to
Is
0.
equal to 0. But
Therefore, it is important
P3
to
is
say. Bolo.
what? मतलब components
P.
की फॉर्म में लिखना है इसको.
Of course. Then
But
Px of all will be equal to
but
0 and sigma of Py will also be 0. This is the way you write. Law of
अच्छा
conservation. हाँ, तो be forgotten ना यही तो problem है. So you can imagine what will happen on the if you don't look back and start revising everything. On the last day, सारे 6 चैप्टर गायब हैं दिमाग से 5 चैप्टर.
12 j cap plus for
जी
minus 40 sin theta
जी
is equals to 0.
J is not required now.
हाँ नहीं
This is
हटा
okay. This is fine. Similarly for x-axis, y-axis.
16 minus
G.
40 cos theta.
Why is it 40 again? अच्छा, because this is 40. ठीक है? Correct है? So cos square theta plus sin square theta is 1.
कॉमन ले लेते हैं 4 हटा देते हैं इसमें से.
Great man. Tremendous maths.
Three upon 10 and cos theta would be 4 upon 10. Yes. Yes, sir.
G. So, but you have to find the mass of the third.
What the?
Yes. So इसमें you didn't have any. So you have used the momentum of first, velocity of the third, but where is the mass of this in the equation? ये तो momentum है ही नहीं, ये तो सिर्फ velocity का component है. ये momentum है क्योंकि 12 into 1 करा है. Okay, so this
ये
is
M3.
12 into. हाँ, वो लिखा ही नहीं ना.
बहुत बढ़िया. अब और मुश्किल हो गई.
So you need to go back and revise momentum first. Because seemingly you're not in touch with momentum at all. कि कैसे लिखते हैं उसको. इतने 45 भी आगे नंबर. I'm surprised. I would have given you 0 if I see this. पेपर काट दो, कुछ नहीं आता. Momentum conservation लिखने नहीं आती.
आज लॉज ऑफ मोशन दोबारा रिवाइज करने
पढ़ो भाई. लॉ सिर्फ momentum पढ़ लो. I think this will fetch you good marks. Momentum. Pick up one topic a day and finish it off. Don't try to do everything. So I'll do Newton's second law today only. That's all. Don't try to do everything. कोई फायदा नहीं होता नहीं है.
ठीक
Your next step actually is you should go for test also, and you should do your school paper 11th standard physics. वो आंसर शीट मिली, you were sending me a PDF.
हाँ
उससे
मैं
पता चल
आपको
जाएगा कौन कौन से क्वेश्चन हुए नहीं यार. You can
ठीक
revise those topics and see where are you getting stuck.
ठीक है
तो मुझे तो पेपर बहुत ही स्ट्रेट फॉरवर्ड लगा था. So where is the confusion? मैंने सुनी सारी बातें, मैंने वो भी नोट करा कि कहाँ you were jittery. नहीं नहीं, मैंने ये लिखा है फ्रिक्शन अपोजेस relative motion. So not very clear.
ठीक
Pick up my assignment, just find momentum questions. Do the momentum questions. Leave it. Then next day go and do second law of motion. Then do third law. वो बड़ी अच्छी तरह से organized है sheet.
ठीक पहले मैं वो कर लेता हूँ.
हाँ.
मोमेंटम वो ना लीनियर कंजर्वेशन और
जी.
इम्पल्स सॉर्ट ऑफ
हाँ. Impulse is short duration force. Impulse force.
ठीक है ओके. बट ये क्वेश्चन अच्छा था, कहाँ से मिला
कौन सा question?
ये बॉम्ब?
Open the books which your mom has purchased. All the questions are from there. I have not
सरदान
created this.
सरदाना.
हाँ, सब में है. वो तो मैंने बताई थी. Your mom had already bought some books. I'm not sure which one was it, but all the books, these 10, 12 questions are very standard.
ठीक
These are used to teach the initial concepts of center of mass, and then of course you need to practice. But काफी कुछ नई नई चीजें पता चलती हैं. Momentum और center of mass कैसे इकट्ठे हो रहे हैं, क्या हो रहा है. Gives you a very nice.
ठीक.
How did you do this now? Mass लिखा.
हाँ M3 लिख दिया.
ठीक है. Now solve it. Eliminate
Solve
now.
it?
हाँ, eliminate M3. Oh, भाई, if you
नहीं
do squaring of both the sides, what will you get? M3 square, 40 square, sine square theta, right? And if you do squaring of this side, what will you get?
M स्क्वायर. एक मिनट ठीक है.
Add 1 and 2.
हाँ यानी ऐड क्यों करना?
क्यों?
रेशो
क्योंकि
ले लो.
थीटा हट जाएगा.
अरे रेशो ले लो.
क्यों? तो उससे थीटा कैसे हटेगा?
टैन थीटा बन जाएगा. टैन
थीटा
स्क्वायर
पता ही नहीं है. We don't know थीटा.
टैन स्क्वायर थीटा बन जाएगा ना उससे.
निकालना ही नहीं है. I have to find the mass ना. If I add them, sine square theta plus cos square theta is 1.
अच्छा ठीक.
Got it? So वो ठीक है. उससे भी आएगा because you will know theta, you will confine M3. But a shortcut is this: just add and finish it off.
तो 2 फिर 2m3 स्क्वायर
आ तो गया. Yeah, exactly. Into 40
प्लस
square into 40 square
1600
into 2.
इज इक्वल्स टू.
What is this 2m3 square plus multiply?
नहीं एक मिनट लो, आप ऐड कर रहे हैं ना.
हाँ. So
तो
दोनों इकट्ठे हो
40
जाएंगे ना.
हाँ तो
तो 40 स्क्वायर भी तो होगा.
2m3 स्क्वायर आ जाएगा ना.
Into 40 square. Why
अच्छा
plus, man? Are you
ठीक है
drunk?
सॉरी.
What the hell are you saying? ज्यादा प्रैक्टिस कर ली क्या केमिस्ट्री में? सारी फिजिक्स भूल गई, मैथ्स भूल गई. ठीक है. 1600. 2 भी नीचे आ गया.
उसमें चाय पीता हूँ. चल ठीक है.
मैं तो जाके भी कॉफी पी रहा हूँ.
बहुत जरूरत है लगता है.
वो मैन, फिजिक्स मैथ्स
सब भूल गया मैं लगता है.
यू प्रिपेयरिंग टू बी एन एस्ट्रोनॉट, मून पे ही जाके क्लियर होगा पेपर तुम्हारा। चार
इसरो
सौ
वाला मुझे
ठीक है, 400 आ गया, ठीक है, 400 बाय 1/800, M3 आ जाएगा, 1/20√2,
1/8,
408 ठीक है,
तो
2√2,
M3 आ जाएगा 1/2 रूट
1/2√2, यस, kgs, डन। ठीक है जी। So what you do, please go back and you have forgotten vectors and also you have forgotten the basics of momentum. It's wiped out of your mouth. Vector तो आता ही नहीं है दिख रहा है. You were not able to do resolution. You were not able to do anything in vector also. कोई खास नहीं था. Which was generally very straightforward. मतलब being able to resolve velocity into sin theta and cos theta में you wrote 40j and 40i, which is absolute lack of practice. बैठा इसलिए नहीं है क्योंकि practice नहीं है. Kindly start doing it. All your assignments will get back to good shape. क्योंकि फाइनल एग्जाम आते आते पता ही नहीं चलेगा, टाइम निकल जाएगा. प्लीज कंप्लीट असाइनमेंट्स, बैठा नहीं दिमाग में. ठीक है जी.